Hello guys. In this video, we will be discussing about the regulation of the blood pressure. So, we have short-term regulation, intermediate type of regulation, and long type of regulation is there, right? We all know that. So, in this video, we will be discussing about the intermediate type of the regulation. Okay. So, uh, it occurs. So first of all, we will be highlighting or we will be discussing about the bullets that we can see here. So first of all, it occurs, the intermediate type of regulation occurs in minutes to hours if there is any decrease or increase in BP. The reflex or the pathway which if there is an increase, the BP has to be decreased. So that occurs in minutes to hours, and it can be last for days. Control BP by altering blood volume. Okay, so it occurs by three mechanisms: renin angiotensin mechanism and capillary fluid shift mechanism, stress relaxation and reverse stress relaxation. Okay, so first of all, renin angiotensin mechanism. If there is a first of all, we will be starting from here. Okay, if there is a decrease in BP, it activates. If there is a decrease in BP, it activates juxtaglomerular apparatus, which in turn releases renin. Okay, what the renins do, you know? This renin convert angiotensinogen to angiotensinogen 1, and angiotensinogen 1 is further converted to angiotensinogen 2 by the enzyme angiotensin converting enzyme, which is present on the lungs. The role of the angiotensinogen 2 is it is a potent vasoconstrictor. Okay, it is a potent vasoconstrictor which constrict the blood vessels. When the blood vessels are constricted, this is the blood vessels. When the blood vessels are constricted, the size reduces to like this. Then the flow of the blood increases. So the BP is increased. Okay, so increase in BP it causes renal retention of salt and water. So what are the actions of the final product that we got here is angiotensinogen 2. What are the actions of the angiotensinogen 2? Okay, first of all, the main action of the angiotensinogen 2 is first of all, the main action is I will be writing, it is a potent vasoconstrictor. It is a potent vasoconstrictor. Okay, it is a potent vasoconstrictor that increases the blood vessel, which leads to increase in BP. Okay, so next is that the angiotensinogen 2 increases synthesis and secretion of aldosterone, which increases sodium and water reabsorption from the kidney. So sodium and water reabsorption from the kidney occurs when the angiotensinogen 2 is activated. How the angiotensin 2 have it will increase the synthesis of secretion of aldosterone. Okay, so it is one of the thing, and it causes contraction of the mesangial cells. If there is a contraction of mesangial cells, there is a decrease in GFR. Then we have told that is a potent vasoconstrictor. So it constricts the renal arterioles. Less fluid filters through the glomeruli into the tubules. Okay, so the blood inside or the blood volume inside the glomeruli increases. It is not filtered to kidney. So what will happen, you know, the blood pressure is increased. Then it has a direct action on a renal tubule. What is the action, you know? It increases sodium and water reabsorption from proximal convoluted tubule. Okay, and then it will act on brain, increase water intake and secretion of vasopressin and ACTH. So the total result is renal retention of salt and water, decreases urine output. Okay, so when there is only urine output decreased, in the blood volume increases. When the blood volume increases, the vasoconstriction occurs or the BP is increased. So next we will be discussing about the capillary fluid shift mechanism. So I will be explaining in detail about this. So what do you know? This is the capillary. When there is a blood flow to the capillary, when there is a high blood flow to the capillary, this is the water, this is the blood, this is the molecules. When there is a high blood flow, the molecules are rushed, are highly concentrated. Okay, So this causes the molecules, the fluid to pass to here it is interstitial space, molecules to pass to here, that is interstitial space. So the when there is a increase in BP, when there is increase in BP or blood volume increases, it will cause the movement of the molecules or movement of fluid into the interstitial space. So what will happen? The interstitial space fluid will increases and the BP is here is decreases. How the volume is decreased? No, when the fluid goes here, volume is decreased and the BP in turn BP is decreased. Okay, so we can read this. When there is an increase in BP, increase in mean capillary pressure, the pressure is increased. Shift fluid from the circulation into the interstitial fluid. I told that. Decrease in blood volume and restores BP. Okay, I hope it is clear. And opposite is happening in another case. If there is a decrease in blood pressure, very slow blood pressure, the molecules are like this. Okay, so what will happen? Here in interstitial space also there is molecules. If there is a decreased blood pressure, the molecules or the fluid will come into the interstitial into the blood vessel. Since here the blood volume is decreased, BP is decreased, the fluid from the interstitial space move into here. Okay, so what will happen? When it is moved into here, the BP is the decreased BP is regulated. Okay, so we can read this. Decrease in BP, decrease mean capillary pressure, absorption of fluid from the interstitial space. I told that into circulation, increase in blood volume restores BP. Okay, I hope that it is clear. Then stress relaxation. Then we have stress relaxation. So what is the meaning of stress relaxation? I will be explaining this. Okay, so what is happening? This is the blood vessel. Here we can see smooth muscles. Okay, smooth muscles are present in blood vessel. When there is an increase in BP, BP is increased. BP is increased means the walls of the vessels are stretched. Okay, when there is BP is increased means here the molecule, the fluid is traveling like this. Severe number of fluid is traveling like this. So it will cause stretching of the when there is a movement of fluid, it will cause stretching of the vessel wall. So in turn, what vessel wall do? So this vessel wall, when there is a stretching, this vessel wall, the smooth muscle, this is the smooth muscle, this is the smooth muscle. Okay, this is the smooth muscle. What the smooth muscle do? The smooth muscle will relax. This smooth muscle will get relaxed. So what will happen if this get relaxed? If this get relaxed, what will happen? It will be like this. Okay, so what will happen? The movement of blood flow is easy. So the BP is increased, BP is regulated. Okay, so we can read this. Increase in BP, stretch of blood vessels, continuous stretch causes relaxation of the blood vessel, decrease in BP. That relaxation of blood vessel means the smooth muscle will get relaxed. Okay, then reverse stretch relaxation means same concept in reverse. If there is a decrease in BP, decreased stretch of blood vessels. If there is a decreased stretch of blood vessels, tightening of the blood vessels will occur. That means if there is, this is the, so I will be explaining, then only you will be understanding. This is the blood vessel. If there is decreased BP, BP is decreased. So BP is decreased means what? This the BP is decreased means the blood volume is decreased and the movement of blood flow is decreased. So the smooth muscles are there. So what will happen? If there is no constriction, constriction is not there. So what will happen? The blood flow is flowing like this. So if there is a decreased BP, it will cause the vasoconstriction will be occurring. So when the vasoconstriction occur means this will come down. This both will come to here and it will be like this. So the movement of blood flow is restricted to this area. So in turn the BP is increased. So decrease in BP, stretch of the blood vessel. When there is a stretch of the decreased stretch of the blood vessel, there is no structure of the blood vessel, that can cause tightening of the blood vessel, vascular tone adjustment. Okay, So this is the basic thing that you have to understand in this case. Okay, I hope that it is clear for you. Thank you.